Metrication or metrification is conversion to the metric system of units of measurement. Worldwide, there has been a long process of independent conversions of countries from various local and traditional systems, beginning in France during the 1790s and spreading widely over the following 2 centuries. But the metric system has not been fully adopted in all countries and sectors. Overview. In 2006, 3 countries did not mainly use the metric system: the United States, Burma, and Liberia. In the United Kingdom, metric is the official system for most regulated trading by weight or measure purposes, but some imperial units remain the primary official unit of measurement. For example, miles, yards, and feet remain the official units for road signage, and use of imperial units is widespread. The imperial pint also remains a permitted unit for milk in returnable bottles and for draft beer and cider in British pubs. Imperial units are also legal for use alongside metric units on food packaging and price indications for goods sold loose, and may be used exclusively where a product is sold by description, rather than by weight, mass, volume. E.g., television screen and clothing sizes tend to be denominated in inches only, but a piece of material price per inch would be unlawful unless the metric price was also shown. Some sources now identify Liberia as metric, and in Burma it was announced in 2013 that the country is preparing to adopt the metric system. Both Burma and Liberia are substantially metric countries, trading internationally in metric units. Visiting advocates of metrication have stated that they use metric units for many things internally, with exceptions such as old petrol pumps in Burma, calibrated in British imperial gallons. These and other countries have adopted metric measures to some degree through international trade and standardization. For example, Sierra Leone switched to selling fuel by the litre in May 2011. The United States mandated the acceptance of the metric system in 1866 for commercial and legal proceedings, without displacing their customary units. The United Kingdom followed suit in 1897, and did not make the use of metric units compulsory for most purposes until 1995. In 1971, the National Bureau of Standards completed a 3-year study of the impact of increasing worldwide metric use on the U.S. The study concluded with a report to Congress entitled A Metric America, a decision whose time has come. Since then, metric use has increased in the U.S., principally in the manufacturing and educational sectors. Public Law 93-380, enacted 21 August 1974, states that it is the policy of the U.S. to encourage educational agencies and institutions to prepare students to use the metric system of measurement with ease and facility as a part of the regular education program. On 23 December 1975, President Gerald Ford signed Public Law 94-168, the Metric Conversion Act of 1975. This act declares a national policy of coordinating the increasing use of the metric system in the U.S. It established a U.S. Metric Board whose functions as of 1 October 1982 were transferred to the Department of Commerce, Office of Metric Programs, to coordinate the voluntary conversion to the metric system. A number of jurisdictions have laws mandating or permitting other systems of measurement in some or all contexts, such as the United Kingdom, which still uses many imperial measures, such as miles and yards for road sign distances, road speed limits in miles per hour, pints of beer, and inches for clothes. Most countries have adopted the metric system officially over a transitional period where both units are used for a set period of time. Some countries such as Guyana, for example, have officially adopted the metric system, but have had some trouble over time implementing it. Antigua and Barbuda, also officially metric, is moving toward total implementation of the metric system, but slower than expected. The government had announced that they have plans to convert their country to the metric system by the first quarter of 2015. Other Caribbean countries such as St. Lucia are officially metric but are still in the process toward full conversion. The European Union used the Units of Measure Directive to attempt to achieve a common system of weights and measures and to facilitate the European single market. Throughout the 1990s, the European Commission helped accelerate the process for member countries to complete their metric conversion processes. The United Kingdom secured permanent exemptions for the mile and yard in road markings, and for the pint of draft beer sold in pubs. In 2007, the European Commission also announced that it was to abandon the requirement for metric-only labeling on packaged goods, and to allow dual metric imperial marking to continue indefinitely. Other countries using the imperial system completed official metrication during the second half of the 20th century or the first decade of the 21st century. The most recent to complete this process was the Republic of Ireland, which began metric conversion in the 1970s and completed it in early 2005. In January 2007, NASA decided to use metric units for all future moon missions, in line with the practice of other space agencies. The United States, the United Kingdom, and Canada have some active opposition to metrication, particularly where updated weights and measures laws would make obsolete historic systems of measurement. Other countries, like France and Japan, that once had significant popular opposition to metrication, now have complete acceptance of metrication. Before the metric system, the Roman Empire used the pes measure. This was divided into 12 unciae. The libra was another measure that had wide effect on European weight and currency long after Roman times, e.g., pound. The measure came to vary greatly over time. Charlemagne was one of several rulers who launched reform programs of various kinds to standardize units for measure and currency in his empire. But there was no real general breakthrough. In medieval Europe, local laws on weights and measures were set by trade guilds on a city-by-city basis. For example, the ell or ell was a unit of length commonly used in Europe, but its length varied from 40.2 centimeters in one part of Germany to 70 centimeters in the Netherlands and 94.5 centimeters in Edinburgh. A survey of Switzerland in 1838 revealed that the foot had 37 different regional variations, the ell had 68. There were 83 different measures for dry grain, 70 measures for fluids and 63 different measures for dead weights. When Isaac Newton wrote Philosophiae Naturalis Principia Mathematica in 1687, he quoted his measurements in Parisian feet so readers could understand the size. Examples of effort to have local intercity or national standards for measurements include the Scottish law of 1641, and the British standard imperial system of 1824, which is still commonly used in the United Kingdom. At one time Imperial China had successfully standardized units for volume throughout its territory. But by 1936 official investigations uncovered 53 dimensions for the chi varying from 200 mm to 1250 mm, 32 dimensions of the Cheng, between 500 milliliters and 8 liters, and 36 difference in ranging from 300 grams to 2,500 grams. However, revolutionary France was to produce the definitive international system of units which has come to be used by most of the world today. The desire for a single international system of measurement came from growing international trade and the need to apply common standards to goods. For a company to buy a product produced in another country, they need to ensure that the product would arrive as described. The medieval ell was abandoned in part because its value could not be standardized. One primary advantage of the international system of units is simply that it is international, and the pressure on countries to conform to it grew as it became increasingly an international standard. However, it also simplified the teaching and learning of measurement, as all SI units are based on a handful of base units, using decimal prefixes to cover all magnitudes. This contrasts with pre-metric units, which largely have names that do not relate directly to one another and are related to one another by inconsistent ratios which must simply be memorized. As the values in an SI expression are always decimal and mixed units are not used with SI, measurements are easy to add or multiply. Moreover, scientific measurement and calculation are greatly simplified as the units for electricity, force, etc. are part of the SI system and hence are all interrelated in a coherent manner. Standardization of measures has contributed significantly to the Industrial Revolution and technological development in general. SI is not the only example of international standardization. Several powerful international standardization organizations exist for various industries, such as the International Organization for Standardization, the International Electrotechnical Commission, and the International Telecommunication Union. Forerunners of the metric system. Decimal numbers are an essential part of the metric system, with only one base unit and multiples created on the decimal base. The figures remain the same. This simplifies calculations. Although the Indians used decimal numbers for mathematical computations, it was Simon Stevin who in 1585 first advocated the use of decimal numbers for everyday purposes in his booklet Athena. He also declared that it would only be a matter of time before decimal numbers were used for currencies and measurements. His notation for decimal fractions was clumsy, but this was overcome with the introduction of the decimal point, generally attributed to Bartholomeus Pitiscus, who used this notation in his trigonometrical tables. In his essay Towards a Real Character in a Philosophical Language published in 1668, John Wilkins proposed a system of measurement that was very similar in concept to today's metric system. He proposed retaining the second as the basic unit of time and proposed that the length of a pendulum which crossed the zero position once a second should be the base unit of length. This length, for which he proposed the name standard, would have been 994 millimeters. His base unit of mass, which he proposed calling a hundred, would have been the mass of a cubic standard of distilled rainwater. The names that he proposed for decimal multiples and subunits of his base units of measure were the names of units of measure that were in use at the time. In 1670, Gabriel Mouton published a proposal that was in essence similar to Wilkins' proposal, except that his base unit of length would have been 1/1000th of a minute of arc of geographical latitude. He proposed calling this unit the virga. Rather than using different names for each unit of length, he proposed a series of names that had prefixes, rather like the prefixes found in SI. In 1790, Thomas Jefferson submitted a report to the United States Congress in which he proposed the adoption of a decimal system of coinage and of weights and measures. He proposed calling his base unit of length a foot, which he suggested should be either 3/10 or 1/3 of the length of a pendulum that had a period of 1 second, that is 3/10 or 1/3 of the standard proposed by Wilkins over a century previously. This would have equated to 11.755 English inches or 13.06 English inches. Like Wilkins, the names that he proposed for multiples and subunits of his base units of measure were the names of units of measure that were in use at the time. The great interest in geodesy during this era, and the measurement system ideas that developed, influenced how the continental U.S. was surveyed and parceled. The story of how Jefferson's full vision for the new measurement system came close to displacing the Gunter chain and the traditional acre, but ended up not doing so, is explored in Andrew Linklater's Measuring America.